Welcome back, everybody. We're going to address the rocket problem that we did in a previous video up on the whiteboard. And I've got an image of that whiteboard here on the Excel sheet. And what's going to happen here is we've got the rocket starting at y equal to 0 with a velocity of 0, and it undergoes an acceleration from the engines. Now the engines will be pushing up with an acceleration, but gravity will be pushing down with its acceleration. So the acceleration will be t minus g, or t plus negative g is actually the way I'm going to address this here in a little bit, but you know that's t minus g. And that's for as long as the engines are running. And so we're going to say for t less than or equal to t rocket, and that's what we're seeing right here. We don't have that designated yet, but we will. Once the rockets are done burning, then we get a negative g here for the acceleration due to gravity. So the acceleration will only be due to gravity. Now the rocket will continue moving up. It's like when they throw a ball in the air, it moves up until gravity stops it, and then it comes back down. And so this rocket will be moving up under the influence of the rocket engines, but then when the engines are done, it's still going to move up until gravity overtakes the velocity, bringing it down to 0, and then brings it back to the ground. All right, so a couple of things here. We determined that the velocity was equal to the previous velocity plus the acceleration times time, and the position was equal to the previous position plus velocity times time. And we're going to take a look at this real briefly on a spreadsheet and kind of see what we end up with. So here on the middle portion of this spreadsheet, you'll see some initial parameters. The acceleration while the rockets are firing is going to equal h3, which is h13, which is the thrust, plus negative 9.8, which is the acceleration due to gravity, right? So I use a plus sign in here, but I make the gravity equal to negative 9.8. And then the acceleration is just going to equal negative 9.8 when the rockets are no longer going. I've set rockets equal to 10. I could set that to anything I want it to be, but we're going to say that it's equal to 10. And we're going to use a time interval of 1 second. So over here on column 2, you can see in column 1, I've got time, velocity, and height with their symbols and units. And then I start everything at 0, right? The time is 0, the velocity is 0, and the height is 0. But then my time will go up by some increment. Now I could have put in 1, 2, and 3 and just copied down, but I might want to change that time increment. So I just said, hey, let's make the time equal to A2, which was the time previous, plus H10, which is the time increment. Notice H10 has got a dollar sign in front, right? So if I drag this down, then you can see that H10 stays the same, but A4, 5, and 3, and whatever, those are all going up as I take that down. Then the interesting one here really is the velocity. So the velocity equals the previous velocity, so that's b2. But then the acceleration, I'm going to use this if statement in here, right? And then delta t or dt, the time interval, is h10, and that just stays the same the whole time. But let's look at this if statement. If a3, that's the time, and that's a relative reference. If a3 is less than h7, that's a fixed reference, that's the rocket time, then my acceleration is h3, that's the green one. You see, notice it's green up here and green in here. And then h4 if it's not less than or equal to, or less than, strictly less than 10. All right, so if I pull this down, what are you going to see happening? The A3 becomes A4, A5, A6. That's the previous, or that's the time interval, rather. And then notice B2, which was the previous velocity, right? B2 becomes B3, B4, etc. And then H7, H3, and H4 remain fixed, as does H10. And then finally, my height in cell C3 is the height from C2 plus my velocity, which is here in B3, times the time interval, right? And that goes with this equation right over here. All right, and if I copy that down, you'll see that C3 becomes, or C2 becomes C3, C4, And then B3 becomes B4, B5, B6. But H10 remains the same. All right, so that's a setup for the spreadsheet. And then what happens when I do a copy is I'm basically doing the same calculation over and over again. And that is a loop. So we'll just go to 60 seconds. That is a loop. And you'll notice here at about 41 seconds, my positions are negative. And that's because I'm below ground here. So this is actually our landing point right about here. Somewhere between 40 and 41 seconds is my landing point. And then the rocket slows to 0 somewhere between 22 and 23 seconds, right? Because the velocity goes from positive to negative. So somewhere in there, it had to have been 0. When did that happen? I would have to make smaller time increments to actually figure out when that took place. Okay, so copying and pasting or pulling down, that's basically running a loop. And that's what we want to do in Matlab. So let's take a look at Matlab. Okay, so I've set up an M file. I've called it Rocket Loop. I do a clear CLC like I always do. And a couple of comments. This program will use loops, and you can read those as easily as I can. First thing I want to do is set the initial parameters. So that's going to be similar to this bit of information that I have in the spreadsheet. So I want something like that in the Rocket file. Okay, so here's my initial parameters. The thrust acceleration is 25. I put units in comments, and I comment about what it is that I'm talking about. G is negative 9.8. The rocket firing time is 10. My time interval is 1, and my initial positions are all 0. Initial velocity, initial time. That's all going to be equal to 0. Okay, so there's my initial parameters. Now we want to set up the loop. Okay, so here's my loop. I'm going to use a for loop because I know I want to do this for 50 seconds, right? I did it on the spreadsheet for 60, so let's go ahead and change this to 60. I know I want to do it for 60 seconds, and I'm going to put dt as a time interval. By default, dt is 1. If I don't put anything in there, the loop will go around and the increment will be steps of 1. But it could be I'm going to want to make that something different than 1. So I could change dt to something else. So I go ahead and put that in there in case I want to make a change later. An if statement that says if the time is less than t rocket, then my acceleration is t plus g. Here's t, 25, and here's g, 9.8, negative 9.8. If it's not less than t rocket, then my acceleration is just the acceleration due to gravity. And then the two statements that you saw on the whiteboard, basically this is what we had on the spreadsheet. The velocity will become the previous velocity plus the acceleration times the time interval. Position will become the previous position plus the velocity times the time interval. Okay, and let's go ahead and run this. And so you can see all of the information over here, right? And I didn't hide any of my calculations for acceleration and velocity and for position or time. So those are all sitting here on that. Well, there wasn't a time one in there, but they're all sitting in here. And then you can see my values up here. So my final time was 60. My velocity is minus 347.8. And my position is minus 4407. If we go back to the spreadsheet, at 60 seconds, my velocity is negative 363. So it's a little different than what I've got here. And my position is negative 5334. And that's a little different than what I have in there. And I want to figure out why that is different, but I'm not going to do that on the video. I may hunt that down and then take a look at it later. They should be the same, but there's got to be something going on that makes them different, and I'm not sure what that is. Okay, so that's a for loop, and then I want to do one more loop, and in this loop, we're going to run the loop over and over again until the rocket reaches the ground. And so I'm going to use a while loop. So what I want to do is, first off, I'm going to take out the for loop. I'm just going to comment that out because I don't want to delete it. And then let's write a while loop, and I'm going to leave my initial parameters up there. All right, so I got some comment here. I'm going to create a while loop, and we're going to run this until the position is less than 0. So I have while y is greater than or equal to 0. I ran this earlier, and I said while y is greater than 0. And because I started at 0, while y is never greater than 0. And so the loop never ran. So I thought that was kind of interesting. So it never did anything when I had greater than 0. So I want to say greater than or equal to 0. And so when it becomes negative, which is after it hits the ground, then it will stop. So I have the same if statement that I had up here. In fact, all of the statements are the same as I had in the for loop, except I did add a timeline, so to speak, so that I could see the time after I calculated all of this to find out when it hit the ground. So we'll go ahead and we'll run this. And you can see that the last iteration here, I have t is equal to 45. My velocity was negative 191 and my position is negative 18. And if I go back to the spreadsheet, I hit the ground in the spreadsheet at about 22 seconds. Oh, no, that's when I turned around. So I hit the ground here at about 40 seconds with a velocity of minus 160 and a position of minus 112 or minus 170. Right, so about 45 seconds here, about 41, 42 seconds there on the spreadsheet. So 41 seconds. So it's a little different. And again, there's something going on that these two are not agreeing, and that's okay. What I would do to troubleshoot, what I will do to troubleshoot actually, is I will run it for small time intervals to see if I can discover what's going on at the very beginning. If I go back to the top, you'll see in my initial, I have 15.2 for my acceleration and my velocity and my initial position. And on the spreadsheet, I've also got 15.2. So the first iteration is the same. So I've got to figure out where is it changing. And we'll take a look at that. Well, I'll take a look at this. And then if I think it's worthwhile, I'll put up a later video. All right, that should get you started on loops. If you have any questions on that, please do leave them in the comments below. Thank you.